Hello, everyone. Welcome to another episode of Azure Episodes Africa. And today's call, we have a developer advocate from PCs and also someone on the team from the Microsoft Learn Students Ambassadors Nigeria, and also part of the Azure Episodes Africa team. So, my name is Babatunde Ahmed, and one of the pioneers of Azure Episodes Africa. Now, I'll pass it over to Sophia to introduce herself. You muted, Sophia. Sophia, can you hear me? Sophia, can you hear me? I don't think so. Okay.
Probably.
Uh, internet. We have on the call Shivay, so I'll allow Shivay to introduce himself.
Hey everyone. First of all, thank you so much, Batunde and Sophia and the entire Learn Student Ambassador Program team to invite me over here for this online session around DevOps. I'm a developer relations engineer, developer advocate at Pieces. So Pieces.app, it's essentially this AI tool that really helps you to completely revolutionize your entire development workflow. So, like, let's say, imagine you are working as a software engineer. Now, in a typical software engineer's life cycle, you do a lot of like research online and go through docs. Then you try to implement that in your code, but then you might be you might have to go back to that research again, and you might spend a lot of time trying to find for that documentation that you have spent like hours and hours. So, like, especially when you're doing a lot of like software development, at times it can be a bit confusing to maintain that kind of focus and also just have everything in place for you. So Pieces like is a really nice developer tool that allows you to kind of revolutionize your workflows by using AI in every step. So whether you're doing research, so you can save code snippets that you can later use in your code base, and it comes with lot of like LLM support, so large language support, that comes inbuilt with a lot of like different IDs like VS Code, where it can answer any question related to your entire code base. It's like really great for onboarding new developers. And then, of course, like you can maintain that particular context about a particular conversation or even about your code throughout your entire life cycle. So, starting with research mode, going to development mode. So, yeah, I mean, you can check it out. We are very young and vibrant community. But yeah, I mean, before that, I have worked primarily in the space or the intersection of like full stack development, machine learning, and MLOps. So a lot of like experience for me comes by contributing to open source projects like Kubeflow, which is an MLOps machine learning pipeline system, and also to Jenkins, which is a CI/CD tool. And I'll talk more about like we'll cover like all these different terms today. So if you are new to DevOps, it's a really important field, especially these days as a lot of like businesses are improving their IT operations and are moving away from legacy systems and adopting like cloud computing, right? So DevOps as a career as well is blue like growing right now. So like a lot of like DevOps roles today. So we'll be talking about that as well. But yeah, over to you, Barton. Like that's quick introduction.
Yeah, thank you so much, Shivay. And I've learned what you guys do at Pieces. Like, I'm starting to join the community. I did see a glimpse of your community call yesterday, so I'm really excited to learn more. And yeah, and for today, this is our first live stream of the year 2024, and would like to start off with the roadmap of DevOps for the year 2024. So if you're a beginner, you're intermediate, or an expert, you want to upskill or you want to get into the field of DevOps, Shivya here will be introducing the steps you can take, and we'll be asking some of the questions that we've gotten over the past few months from people that want to go into this field. So yeah, right on the call, Sophia is back, so I allow Sophia to do our introduction. So over to you, Sophia.
All right. Hi everyone. Sorry, my network got disconnected. I'm Sophia Eribu. I am a backend developer, technical writer, and also a developer advocate at Pieces. And I'm really excited, for for us to have Shivay share his knowledge on DevOps, and I hope that you all listening will learn a thing or two, and I hope I do learn a thing or two as well. So I'm so excited for all this.
Absolutely.
Yeah, thank you so much. Yeah, so we have some questions lined up for Shivi, but I would go ahead with the first question. So the first question is, what exactly is DevOps and how does it differ from traditional approaches to software development?
Yeah. So I think like it's also important to just kind of get a glimpse of what used to happen before DevOps, right? And I'll come back to what exactly DevOps is. So let's just understand that when we talk about something like the 1970s, 1980s, when we just started to put out our first ever PCs and our computers, right? At that time, if you're building an application, of course, it was like really difficult, but mostly your applications were being stored on these single machine, which can be thought of as a server, right? So a single application was being stored on a single machine, and then you would typically create like a local system and serve your application through network requests while that particular application would be running on that server. Now that would have meant that if other people wanted to get access to your application, you would have to always keep that server up and running, right? That's a just a brief about like how standard software was being served to people like during the early 1980s 1990s, when we had like the boom of internet as well. But primarily, like, DevOps kind of stands for a short form for development and operations. So DevOps plays a really important role in the entire software development life cycle, but primarily it is a set of practices that are meant to improve the collaboration between the software development and the IT operation teams, right? So when we talk about like standard software development, we are looking at writing code, the application logic code that is being written for running the actual application. And then of course, when we talk more from the perspective of the IT team, right? IT team is generally looking after maintaining all of the infrastructure, right? So it's mainly meant as a series of processes, and really just focused on automating and monitoring the process of the software integration, testing, deployment, and the infrastructure changes that are required in this particular entire thing. And I have a like a small slide to give a better perspective to everyone in essentially what exactly happens during this entire process, right? So because software development is not just about that, hey, I have written the source code of my software, but then how can I make it accessible to millions of users, right? I can write the code on my local PC, but then how can I make it accessible or available throughout the entire internet or through millions of users? So I'll just quickly also present like a small slide. I have that ready right now. So let me go ahead and quickly share my screen with all of you. So just give me
Yeah,
one
please go ahead.
second. Yeah. So just give me 1 second. Okay, perfect. So it should be there, if I'm not mistaken. So I'll just like talk briefly about the DevOps life cycle over here, right? So primarily, like, I just want to focus on the life cycle. So see, like, what essentially happens is that, as I mentioned, that DevOps is made up of a set of practices that help an organization deliver products faster and facilitating between the integration of the development team and the operations team, right? Now, there are a number of different steps involved in the life cycle of a system. That basically means that as software engineers are working on delivering features, fixes, or updates to a particular system that are closely aligned with the business objective. So, DevOps really is a software development approach that provides better quality software that is deployed and developed quickly, and you add more reliability to your software. So all of these particular steps are what essentially comprise of DevOps. So over here you can see this is like a really basic life cycle where create is basically like, the left hand side you can think of is more from the side of like the software integration. So you are creating the actual software code, then you are planning on some releases, like how are you going to be releasing it. So that's like the dev part, where you then verify whatever changes you have made, and then you package it together in the form of a software. Now from the operation side, that's what is focused on, that okay, like once the software development team has written the software, has written the code, now it's their uh, responsibility to actually go ahead and release it, configure it based on whether it's being released to just some amount of users, or you're releasing it to the entire audience that is there. And then you also monitor, because of course once the software goes live into production, you want to ensure that your software is performing as expected, right? You don't want the performance of the software to go down. We see so many times, like Amazon during, like, let's say Black Friday sale, it will go down momentarily. And just imagine that if Amazon, a site like Amazon, goes down even for a few seconds, how much amount of uh, value it basically drops, in terms of like how much monetary value it can affect. We see it from time to time with like Facebook going down, Cloudflare going down, like GitHub going down, how much it just affects the company. So that is the reason that ensuring proper reliability of your software, so that it is accessible by everyone, you foolproof and test it out so that it can handle the traffic that is expected. Otherwise we see that businesses incur millions of dollars of losses in case their software goes down even for a few minutes, right? And we have seen that from time to time, that how impactful it can be. So that is why DevOps is a really really important piece of every single software company that is releasing some sort of a software. And it really helps to manage both the development and the operation side of things. So yeah, I hope that kind of just puts this into perspective and shares a difference between like standard software development and like what DevOps really encompasses.
Yeah, absolutely. Just have the feedback. I think for startups, many startups go with the traditional way of doing things. You deploy, you try to push your code, but I think with the emergence of GitHub Actions and various tools that we have now, it's, the, I mean, it's most people are seeing it from the aspect of cost. But now
Yeah.
these platforms are there for you to like streamline the entire cost and also like bring on your infrastructure to make it automated. We have Jenkins, we have like Circle CI and the rest of them now, automating the entire workflow for different companies, whether it's big, medium, or small companies as well. Yeah. Thanks for giving a intro on how traditional software development works and how the entire ecosystem is moving towards DevOps and automated environment. So yeah, Sophia would ask the next question. So Sophia, over to you.
Yeah, thank you for that. So I did learn a thing or two from that. So now in your experience here, what tools do you use to implement DevOps practices, and how do those tools help to contribute to an overall workflow when it comes to
Yeah.
DevOps? Yeah.
Absolutely. So as I mentioned, right, that DevOps is not just like some sort of a field in computer science, right? It also is a set of fundamental principles and cultural aspects as well that contribute to the effectiveness of a good DevOps team in any company. So since DevOps emphasizes the collaboration, right, between the development, operations, and cross-functional teams, you need such kind of tools that can help you to get that collaboration, break down the individual aspects, like, because of course the software development team is still focused on writing the source code. And of course, in the case of like DevOps, there's also a lot of like automation involved, right? So it enables teams to automate a lot of the repetitive tasks, such as the build, testing, and the deployment process. And that is where we'll use terminologies like infrastructure as code, monitoring and like CI/CD, which is like continuous integration and continuous deployment. We'll talk more about it later, right? And I know like Babatunde, you also kind of covered GitHub Action, so we'll be talking about that later. But primarily, the set of tools that every particular DevOps team needs to incorporate, uh, or at least what we do at like Pieces as well, is having a really robust CI/CD tooling, because of course CI/CD, again I mentioned we'll talk about that later, but it really helps in helping software developers and the teams to focus on quick and reliable delivery of the software. So once the source code has been written by the software developer, they push their code to, let's say, a Git based system like GitHub or GitLab, and now of course, if in order to make it productionize, you will first build the application to see whether the build is successful or not. Then you'll run some tests on top of it to see that if there have been some changes made into the software code, has it not broken some other parts of the software? Because that is a very common thing that we see, right? That you might have written some source code that is probably across multiple code files, and you might not realize, but it might have affected some other part of the code. You want to ensure that your code is resilient based on any changes that you make. And then as you have tested it, now you want to productionize it, right? You want to go ahead and bring it to production, so that now it can also be utilized by the live audience. And again, like the different kind of strategies that are involved with deployment, those also kind of vary from team to team. You do not normally just release a major change to your software and make it public to everyone. There are different techniques that you use. Some of them are called as like canary deployment, where you only select like a subset of your users, where you are first testing the waters and seeing like whether the code is working fine, the software is working fine, and then you releases in patches, so that you can cover the entire world. So they're like different techniques that you use. So CI/CD tools are definitely a very important aspect, right? And again, like we have a number of different CI/CD tools, GitHub Actions. We have Circle CI, as Babatunde mentioned. We have Argo CD. Like there are a number of different tools that are there in the ecosystem. Now, of course, in addition to that, as I mentioned, that once the software goes into production, it's also really important to ensure that you are monitoring the performance of the model or of your system from time to time. So there are a bunch of different monitoring tools that again are utilized to look at the performance, the reliability, and ensure that uh, our entire platform is always up to date, right? So as we see, like there are a number of different tools that we have. For example, in monitoring, we have things like Prometheus, Grafana, right? Jaeger, all these like different tools that are used for like maintaining and ensuring that the code remains reliable. And of course, then in terms of like deployment, we have an entire structure where we have kind of seen us moving away from having, you know, uh, regular hard drives or servers that were running these particular programs, to now also like involvement with cloud. So cloud and DevOps together works very well, because a lot of like these DevOps practices can be enabled and can help reduce the friction when it comes to adopting these practices when you're using the cloud. So things like containerization, virtual machines, these allow you to basically run your code on some remote machine and not having to be physically there. So like a lot of times, let's say if someone is in a very remote area, they might not have access to a lot of like really powerful machines to serve their code on, right? Today we are like having so many machine learning models being released. Now not everyone has access to the world's best GPUs, but with DevOps, with a cloud, with containerization, right, it actually allows us to access some virtual machines, which are actual physical machines in some huge data center, but you're able to again uh, not only deploy your source code on that, but run it without like with the comfort of staying at your home. So all of this is provisioned due to technologies like Docker, Kubernetes, which are used for again for deployment. So yeah, I mean these are some of the most important tools that I recommend that everyone should learn if you are getting into DevOps. And of course, like there are as I mentioned, like there are different aspects of DevOps, not just like limited to CI/CD or infrastructure as code, right? A lot of like teams also then define the practice. Like, it's not just that you just implement that today I'll deploy my code. You set certain practices, and certain best practices when it comes to like deploying your software, right? And it varies from company to company, so there are different approaches that people apply. Not every, like, there's not really a golden standard to how you should build, test, and release your software. Like every single company or every single project does that on their own. They use different set of tools. They have set different set of SLAs in order to go about doing this. So I hope that answers the question.
Yeah, I mean, that's very valid because when I started learning as well, I was always looking at I mean, when I go into the DevOps field in 2021, I was thinking about what's the best strategy, and I've learned so far through like different companies that use it is that each company have their SLAs and they have like their own time of like the different KPIs they want to meet up to. So you can't expect what Microsoft is doing for DevOps for a startup to doing that. It's quite different because they have multiple projects. But one thing that I've done so far is like what you've mentioned, containerization. Now it doesn't take so much resources to get into the field, and also like in terms of like you don't need the infrastructure to be at your workplace or so. You can use a remote server somewhere, and also it doesn't take as much space that one would assume. You can spin up any kind of I think is it Ubuntu? Is it Python? I mean, you can build these layers of software on top on another to have the entire infrastructure built out. But yeah, I have the next question. I'll go ahead into the next question. The
Yeah.
next question is, how does automation factor into DevOps, and in what ways does it transform the development and deployment processes?
Yeah, so as I mentioned, like automation plays a really, really huge aspect, primarily to enable teams to automate repetitive tasks such as the build, test, and the deployment. So ultimately, automation is actually helping us uh, get more efficient and better consistency and reliability of the software delivery, right? So just imagine a particular, process where every single time that you push some code to your GitHub, you have to manually then take that source code and pull it to your remote server. So let's say that you're having a full stack application. The front end resides and is hosted on a platform like, you know um, Vercel, right? And then, or Azure Static Pages, and then your backend code that exists on a GitHub repository is actually there on a VM instance on Azure, right? Now, whenever you're writing code on GitHub, now you'll have to log in into your Azure VM instance, pull your code from GitHub, and then write a bunch of commands. So, for example, if you're using like an Apache server or a PM2 server, you have to write the that particular steps in order to again push that particular code so that it you can pull it and then you can restart your server to again run it. Um and then, the thing is that these repetitive steps, of course, they are repetitive, right, for a reason. And they also pose a potential security risk because you're continuously trying to access your servers, and you're logging into them, you're continually accessing your server. So by mistake, if you run a wrong command, you might just end up losing your entire data. So in order to reduce that amount of time and physical effort that you're required to continuously run that same process, you have tools like CI/CD, which with just a push of a button, or like, let's say, by defining a particular rule, that let's say that if a software engineer in your team has raised a PR, and then you merge that PR inside of your code, there's an automated process that automatically pulls that code to the VM and then also runs the build to ensure that yes, your code is running properly, then runs all the test cases on its own, and you can define rules on how the deployment of that particular software would look like. So you either, if you're not, let's say, using a VM, if you're using like a container, so it will take that container image, it will go ahead and then turn that into an actual container, and then run it inside of a pod, inside of a Kubernetes container, so Kubernetes cluster. So basically, like these processes which required you to write on, like, every single time the code was pushed, you can automate that. And again, like, that actually does save a lot of time for development teams, because it's a lot faster, a lot more efficient way of being able to do this. And another important aspect that I'd like to probably touch upon over here is infrastructure as code. So infrastructure as code is basically a practice of managing and provisioning infrastructure. So when we say, like, what is infrastructure, infrastructure basically means any VM, right? From time to time you might want to set up a new VM, like, let's say if you are trying to build, like, so in software development, a great DevOps practice is also to have different set of environments. So you'll have your development environment, you'll have your staging environment, and your prod environment. So typically in the dev environment, that's where the software engineers will first push their code. Then the code is then tested in your staging environment to see if it's correct or not. And then finally, once it passes all these checks, you'll push it into the production environment. Now, once you have, like, let's say initially set you're initially setting up your project, you need to, of course, like, there are a number of steps involved in order to set up a VM. You need to basically give, like, the name of the VM, choose what kind of type of system you want, like, and then set up the networking rules, and all of this can take a lot of time. Now, how about, like, if we wanted to again automate this process as well? You want to create, like, multiple new environments. Would you have to go through that entire lengthy process again and again? No, right? In order to save time, you can leverage things like Terraform or infrastructure as code that allow you to just define, okay, I want to set up this particular VM. These are the characteristics through code. Like, it's similar to like a JSON like language. So it's like, for example, I'm talking about like Terraform. So it's like similar to like a JSON like language, and then you can just invoke it whenever there is a requirement, without again having to put in all that effort manually. So yes, I mean, automation plays a very important role, whether it's with software delivery and ensuring that we have reliable software, and it also, like, is involved with reporting. Because let's say that today your software goes down, and of course, I mean, humans cannot, like, look at whether the software is performing 24 hours. Like, they cannot look at the dashboards at all times. So you want a way to get, like, a pager duty alert, or an alert as soon as your system goes down or any part of your system fails. So your monitoring solution will look at, okay, like, these particular set of APIs or this particular component of your software failed. So now it should automatically send an alert to, through email, through call, or whatever, in order to get the DevOps engineers back into action so they can fix that. So that again is a process of automation, right? Where we are making the entire life cycle of ensuring that the software is reliable. And in case of a system failure, we are able to alert the concerned teams, and they are able to quickly get into action. So that is, like, automation is a very, very important role in terms of like development and deployment. Yeah.
Yeah, thanks for giving insight into that. I just want to point out the tool set. I mean, you've explained how the entire pros and cons of using automation. But when I did started, I did a little bit of research and I noticed that Python, you need to have like good Python skills to be able to automate scripts. And for Linux, people would accept that you need to understand Bash. Bash scripting is like
Bash.
fundamental. And after learning that, I then moved on to learning infrastructure as a Terraform. And what Terraform is cloud agnostic in certain ways that
Yeah.
it's not tailored towards just one cloud provider. You could use it for AWS, Azure, and the rest of them. And I did understand that each one of these cloud providers also have their own infrastructure automation tool or provisioning. Azure has Bicep, so I think it's so cool because I work with Azure technologies quite a lot. It's so cool
Yeah.
to see that what they've done with Azure, Azure Bicep is that it's more of like you could write it as if you're writing a code. It's you can set variables and parameters and thereafter, and these tools are quite good. In your own opinion, how do you think someone should upskill to learning? Like, what's the approach you'd say someone that is looking into getting into DevOps should go to upskill in terms of automation? Like, what I would like your insights on that.
Yeah, so about to that thing, like you kind of answered a lot of that question yourself. So I think like it's really important to be fundamentally strong in, I would say, four major aspects before you jump into DevOps. You mentioned about Bash programming. Like we use so much of these shell scripting inside of like DevOps, writing these scripts. It could be to migrate a server. It could be to just writing a quick Bash script to automatically pull your code and like run a PM2 log to like do that. And that also requires you to have good foundational knowledge about Linux systems. So having good knowledge about Linux commands, you traditionally use so much of like grep to copy paste items. Like so, having good fundamental knowledge about like Linux commands, and then about shell scripting, and then from a theoretical perspective, I think like it's really important to have good knowledge of computer networks, because so much of DevOps is just revolving around networks, right? Whenever you are sending any requests, of course, software development is not just limited to like you. So when you're doing like as a regular software engineer, I think like the most amount of networking that you'll use is like understanding how APIs function, how the like HTTPS protocol, the FTS protocol, all these different kind of protocols work in order to like send requests, send data across, right? How you binarize your entire data and then send it through a request. So all of those are generally used, but then you go beyond that and understand like concepts like IP, how IP addresses work, because of course like you're linking every single server with a unique IP address. And there's IPv4, IPv6, and in general, when it comes to like just going deeper into like the technical architecture of your entire product, if you're having like a microservices based architecture, every single service is going to be it's going to be served separately. Then how do you communicate between each of them? How do you set up networking and traffic rules between different services? And then also ensure that you have proper firewalls set up in order to maintain security, right? So computer networking is an important and integral aspect of DevOps. And if you don't know, or if you're a bit weak, then a lot of times you'll simply not understand what you're doing. So if you want to understand what you're doing, especially when setting up the infrastructure, it's important to understand networking. And then to a certain extent, I think just understand like how operating systems work. That's really important anyways if you're in the tech industry. Like a bit of databases. I mean, I'll not go too into databases right now, but yes, like computer networking is a huge must. And like I think operating systems are good to have. But in addition to that, like once you have kind of done all of this, I think like knowing a programming language is always helpful, because generally like sometimes people feel that I can get into DevOps because I'm not good at like data structure algorithms. Now it's fine if you're not that good at that. You can get into DevOps, but I think because you're going to be working so closely with the software engineering team, you need to at least know how their software works, because then you'll be able to devise a good DevOps strategy in order to then productionize that code. Because if like let's say there is a microservices architecture inside of the software, right, that is being written, you need to know like what are the different microservices and how do they communicate with each other, what is the database they're using, because all of that will be your responsibility to come and deploy it when you are learning. So just having that basic knowledge of software is really good to have. And then you jump into the different categories of DevOps, right? So we start with the entire like CI/CD pipeline. So for that, you learn about continuous integration, deployment, and the different tools that are associated. You learn a lot of like YAML. So YAML is like you write a lot of YAML in DevOps. It's important that you learn that. So yeah, you start with CI/CD. Then of course like there are different verticals within DevOps, right? It's not just like limited to CI/CD. Like there's monitoring, there's infrastructure as code, there is of course like CI/CD is there. But I would say that in order to really good to become good at even something like infrastructure as code, learning the basics of CI/CD is important. So yeah, I mean, once you're done with that basic homework of learning things like computer networking, Bash, and all, then CI/CD is there. You learn the different tools, then you implement them, and like I think DevOps, it's really important that you implement things. So you can, of course, a lot of these particular open source tools also provide you to like set it up locally yourself. And then I think it's also important to understand like how VMs work, right? Because you will be setting up a lot of those as well when you're dealing with DevOps. Some amount of like network security, that's also like good to have. So these are some of the skills that will help you to upskill yourself and become become better as a DevOps engineer.
Yeah,
Yeah.
man, that was like really awesome, and and I learned so much. So I have a question. So in your experience as someone that has worked in DevOps for quite some time, what are some challenges that organizations face when adopting some DevOps practices, and what are some strategies that can help overcome such challenges?
Yeah. And like I like to probably divide this into like just cultural challenges within the teams, and then also with respect to the infrastructure that is currently in place. So I feel like if you just talk about like culturally, right? This probably this is not really relevant to today's startups, by the way, because like the startups are obviously like using a lot of latest tech, but generally like the companies that have been around for like 20-30 years, which have always relied on serving their entire architecture through local systems. So they don't want to move to the cloud, let's say. So it's more on the challenges that you face when dealing with team members that might be just reluctant to adopt new practices, or might be they might feel threatened by the changes that DevOps brings. Because just understanding, right, DevOps is automating a lot of these different things. There's a special IT guy who IT person who was just managing the getting the source code and then deploying it themselves, but they might be, let's say, replaced by an automation of using something like CI/CD. So generally I think it's more of like culturally there. But of course, in terms of also like, this also applies just to the legacy software, right? Like legacy infrastructure, those particular teams that have been having their systems for like 25-30 years, that infrastructure might not directly support. So you'll need to, of course, make certain changes to the code itself and at an architectural level in order to then adopt DevOps. And I think it's also the lack of skills, because organizations might just find it difficult because their current team members have never gotten exposed to DevOps. So a lot of like teams also are today upskilling them, their team members, by participating in a lot of like different certifications. So Azure has a lot of like certifications. Probably Babatunde, you'll be able to share more insights into that. But that's generally like what we see as the challenge. And I feel like one thing that we generally don't talk about is like the silos, right? So generally what happens is that the software development teams, they want to work on their own thing. They don't want to interact with anyone. They don't want to get in touch with the DevOps team and tell them about how they are going about their business. It happens especially because DevOps is such an important role. It's a interdisciplinary role, right? Because you're working on the intersections of the development team, the IT operations team, and then also the business team. Because DevOps really helps, as we kind of spoke about SLAs. It's a huge business, issue if your software is not up to date, and some people are like getting some other version of the software while some people are getting some other version. So like version controlling, and so given the fact that the DevOps teams operate with so much amount of interfacing between different teams, if your organization uh, has such kind of a culture where there's not a lot of like interaction between different teams, then the like working in silos can be a bit of an issue for teams to adopt, and they need to change their way of working so that we can do that. And given the fact like DevOps, of course, at this point in time, it's not new, but at the same time, the landscape, right? When we talk about like the landscape for DevOps, it's a very very vast landscape. So choosing like the right kind of tools and integrating them at times can be a bit challenging. But I think like in order to basically overcome a lot of these, I think the most important is just helping make the legacy organizations just aware of the benefits that you get with DevOps, and starting with like small, DevOps practices across the organization, showing the benefit that you get, showing them through metrics that how by adopting DevOps they were able to make their operations and deployment probably faster, right? That ultimately then results in better actual throughput for the entire company, right? And then of course like training and upskilling your entire team, or putting in the automation in DevOps, right? And ensuring that the cross-functional teams also are working together and having that shared responsibility, right? Because as we mentioned, like DevOps is a shared responsibility amongst like different teams in order to ensure faster, safer reliability of the software development.
Yeah, true. Yeah, like you're absolutely right. Wow. So I know that you made mention of CICD, or I mean anyone that is interested in DevOps would definitely must have heard of CICD. So in your own words, can you explain the difference between CICD and how that works?
Absolutely. And I think like it'll be good for me to again quickly share my slides. So give me just a second.
Yeah, sure.
I hope it should be available now. I
All
think
right.
it has started to share. Perfect.
Yeah.
So we, yeah, by the way, it has to be the other slide. Yeah, perfect. CICD. Right. So I know like we kind of touched upon a bit of like CICD already. So we'll just quickly jump into, what each of them particularly means. So we'll start first with CI, which stands for continuous integration, right? Now, continuous integration is that part of your entire life cycle where once your software engineer has written the code, then the code will go into, of course you want to ensure that once you have written the code your software is building properly. So there's a build step involved, like you, if you're using like a node.js application, you do npm build or npm run build in order to ensure that yes, whatever changes, whatever new dependencies that you have added to your code, has it not broken the system, right? And then you also run certain amount of tests on your system. So you basically build your entire source code, then you run some tests on it, and then you create an artifact from that. So this artifact is essentially, it could be like a container image if you're using containerization. It could be just the build file, right? Then now you can go ahead and deploy it. So that is the main part of the continuous integration, where it mainly involves with you pushing the code, creating a build, running tests, and creating the artifact from it. But of course, when it comes to like now, you have gone through the entire testing process, your software is ready to get deployed. So that is where the CD part comes in, which is like continuous deployment, right? Where in now once, okay, like the software is ready to be productionized, you'll first probably push it to a staging environment where you would want to just ensure that yes, it works fine. And then once you have tested it out in the staging environment as well, now it comes to productionizing it. Like that means pushing it into the prod, right? And so that it's now accessible to other folks as well. So both CI/CD and like CI part and then CD part involve like a different set of tools that we'll like just quickly touch upon. So of course, like this is what the breakdown kind of looks like. So CI part is what you see on the left with the build, test, and creating the artifact. And then when it comes to actually now pushing the build file, right, through the staging environment and the production environment, that's taken care by the continuous deployment, continuous development. And I think like this should give you a better understanding as well. So let's say if you are having, this is an example of like a container application. So you write your source code, you push it, right? Then basically you compile it to ensure that yes, it's running fine. You're probably running some tests, and you're also doing like a Docker build to create the actual image from it. And then you'll run some tests on it. Like we can have probably a separate session altogether around like software testing, because like there's so many different types of testing. So unit testing, integration testing, automation testing, right? Smoke testing, like there are different types of testing. So you go through all of that process, and once it passes everything, that is when the deployment step comes in. And so for example, like for CIE, right, there are like different tools. There are separate tools that manage both the CI and the CD part. So that is why like I want to like quickly give an example of something like some of the different tools that we see, right? So you have things like Argo CD, we have Jenkins. So something like Jenkins is basically an all-in-one solution, which provides you both the capability of doing the integration part of things and the deployment parts. Something like Travis CI will only do like the CI part. It will help you to build your code and run some tests on top of it whenever you push your code. And the great thing about CI/CD is that you can custom define how that process you want it to. So it's not like a universal solution for everyone. CI/CD tools give you enough flexibility that, based on again your company's requirements on how you deploy your software, you can define that or configure it, right? So I'll go probably a bit deeper into like an example of something like GitHub Actions. So there are like these five main steps involved in GitHub Actions, where you start by defining, okay, like these are the events. Then you define like what job needs to run. Runner is on what system, right, you want it to run, because of course you are building the software, you are running it, so you need like some kind of a hardware where you can basically run your application. So this is like if you're running GitHub Actions, typically GitHub is having a certain Linux machine. You can define your own machine as well, where your entire software will run. And then action are the pre-configured set of like code that actually does something for you. For example, there could be a custom action for deploying your code to AWS, where you define your AWS or like let's say Azure. There could be one for Azure. So like let's say you define your Azure credentials for your VM. So now your code will get pushed to automatically to a virtual machine on Azure. So there'll be a custom action for that. There might be a custom action just to lint your code and check whether your code is properly linted, right? And then like you define the steps that you start by first with giving like a push. So I like probably give a quick sample as well. I think like that might be a good idea to showcase how this process kind of looks like through one of our open source repositories actually. So I'll just quickly show that to you, that we are already running for one of our example projects. So let me go ahead and open this up quickly. So let me share my screen, and I think it should be visible. Okay, perfect. So I'm just sharing my screen. So typically, like if we just give a very rudimentary example of like GitHub action, you define it in this .github uh, directory, and then you define your workflow. So one workflow will do a particular step. So that is why you see over here the different types of things, right? So you define the name, you define when your action is supposed to run, when that workflow is supposed to run. So in this case, you can see that it should run whenever we push on what particular branches, and then of course like whenever you create a pull request, it should also then run that workflow. So again, when a pull request is made on the main branch, it will invoke and run this particular workflow. And then you define the different type of jobs. So in this case, like we have a build job that runs on, so this is the runner which will run on an Ubuntu device that has been set up by GitHub. So whenever you run this workflow, it will instantiate a new Ubuntu machine, and it will run this again on cloud. And then you define the different steps. So in this case, the steps are to check out the code, then set up like Node.js, because this is like a Node.js project, and then install the dependencies, run the tests as well. So you can see like running the test, but before that, you're also ensuring that your project is getting built. So this particular part, like this example, is just for the CI part. You don't see like the CD part. Probably another example that I can show you is for the TypeScript SDK. So we have like a TypeScript SDK. So I can quickly show you that as well. So I think so it should be like I'll just type it over here. So we actually have like one open issue where, for example, you want to like let's say create a GitHub action that can automatically publish your SDK or your npm module to the npm registry, right? So this is like probably one example of the cd part, where like ci part was installing the dependencies and building it, but then something like pushing it, right? So in this case we are basically running a custom action that allows you to publish your npm packets to the npm registry. So this is like an example of your CD part. Now, another example could have been, let's say that once you have built your project, you'll define a custom action for pushing your code to an Azure container service, or it could be also to like a VM. So you could define your secrets that are used to connect to your Azure service and then push it. So again, like this is a great thing about CI/CD, that you can define when that action should run, how it should run, where your code has to be invoked, where you have set up your tests. Everything is very well serviced through CI/CD. So you get a lot of like customization, and again, based on your company's preference, you can run it wherever you want.
Yeah, thank you so much, Shive. And so we're almost at the end of the questions. So the last question I have is just a minute. Let me try to get it. Okay. Okay, yeah, I have it now. So now that you've explained the critical differences between continuous integration and continuous development, um, in fostering collaboration and communication between the development and operations team within a DevOps culture, what strategies have proven effective for you? Like initially, you mentioned that upskilling is part of it. So I would like to know what additional strategies, because a lot of people are now, like, the DevOps culture is now a norm, but we still
Mhm.
have some people that are still hesitant or reluctant to adopt it. So what strategies have you utilized in the past? Have you seen teams utilized to, you know, adopt the DevOps culture?
Yeah. I think it's just being upfront, right? As we kind of have already answered some of the question, I think based on when we were talking about some of the cultural challenges that are there in the teams. I think like a lot of these were already answered in that particular question, but I'll just quickly repeat for everyone's, if someone tuned in later. So as we kind of discovered that yes, a lot of teams work in silos. A lot of times teams are not just technically equipped. So upskilling is a really important aspect. You have to upskill your fellow employees in order to understanding like how DevOps works, for the benefits, educating them about that, and then of course having really open communications using collaborative tools that allow team members to work together seamlessly, right? It could be through issue tracking tools, because of course the cross training and the cross collaboration is really important in DevOps, but especially between the software engineering teams, the business team, and the IT operations teams. So taking like regular feedback and having retrospectives, gathering input from different teams, and really just helping set that what is the DevOps strategy at a particular company, right? Because the software engineering team might say, as soon as we push our code, just deploy it. Why care about like having a staging build at all? Why put in additional amount of time to having to push your code, and then probably having like an entire 1 week of testing before you push it? Why not just push it as soon as the code has been written? Now that's a business decision, right? If there's a company that is wanting to make very quick releases, and they probably might not have a lot of users right now, they might not even require a staging build. They can directly do some basic testing in their locally in their system and push it to prod. That might work if you are really doing like fast iterative, like especially for a new company which is like there to prove to investors that they can build like a quick POC. So if your company is like building a very quick POC, like setting up canary deployment, like staging environment might not make sense, because it is adding time, right? But of course for legacy systems, for systems that are serving millions of concurrent users. You need something like that, because if you don't have that, then it does not make sense, right? So I think it ultimately depends on the business, like business's decision as well. So that is where like the functional teams having to understand like what are the business goals, how the software engineering teams work, and then of course like upskilling all of them about how DevOps can be a great practice in order to make your software delivery more reliable. So it's, I think those are some of the strategies that have worked well. And then like we didn't really touch upon the KPIs as well, because of course KPIs, measuring the success of DevOps, because that is also something that you'll then have to explain to people, like how DevOps is useful. So those are some of the ways in which we can define or defend having DevOps practices in the first place, because you're really trying to identify the areas of improvement in your entire DevOps inside of the organization. So one of the KPIs could be how often are you pushing your code changes to deployment, right, to production? How quickly can you deliver changes and have just a faster time to market, and essentially have a increased customer satisfaction, right? Then how can we change the failure rate in our product? Because this KPI will basically measure the percentage of code deployment that basically results in a failure in production, and then how what is the turnaround time, what is the mean time to recovery, right? So this is a very prominent terminology used in DevOps, which basically tells like what is the time that it takes to recover from a failure in production. A lower KPI for this, like a lower value, will basically mean that teams are quickly able to respond to incidents and restore that particular service efficiently, right? So helping you to minimize the downtime and impact on the users. And then what is the deployment time? How much time does it actually take for the code to be pushed to a Git repository and then into production, right? So deployment time also, plays a very important role. So all of these, factors like these KPIs play a very important role when it comes to uh, adopting DevOps. And I think like these are some of the things that have really helped, at least with the teams that I've been involved with, the cross-functional teams that I have been involved with. And I can like give an example with something that happened at Pieces. For example, like our desktop application is available on Windows, on Linux, on Mac. So based on one of the recent features that we push into production, Windows users face a lot of issues. We received like a lot of complaints because it was like related to OneDrive. And then but the team was proactively able to identify that issue, get on like customer support calls, and then release a patch for Windows only. Now because we have very robust pipelines set up for us, where anyone can go ahead and test out our software, including like the entire community. So we have like this staging dot pieces dot app. I forgot the name of that. Probably Sophie, you can probably share it, where we actively share like all the staging builds and the production builds of the different softwares that we release. So I think like it's again, just to kind of summarize, ultimately it depends on company to company to identify what set of practices are there. DevOps is not like a complete subject that these are the guidelines that you have to follow. It gives you a set of best practices, and which can be tweaked, which can be modified, molded based on the company's usage. And every company then has to ensure and identify what is the best tools that they have to use, what is the KPIs on the basis of which they will set up their DevOps teams. So yeah, I hope that kind of answers the question.
Yeah. That did. So I think probably the last question would be if you can share some link to some DevOps resources that newbies, especially me, can learn from, that would be amazing. And while you share that on the chats, thanks guys for joining. I'm very sure that you learned a thing or two about I'm very sure that you learned a thing or two about DevOps. Don't forget to follow Shivay on Twitter. His username is how develop.
Develop, yeah.
And oh, yeah. And if you are interested in pieces, you can as well check it out on pieces.app. And yeah, so
Yeah.
yeah, does anyone have like a final word to say? Oh, and yeah, Shive, please share the link for DevOps resources as well.
Yeah. So I think of course roadmap.sh, it's a great platform to just learn a basic like what is the roadmap, because there are so many questions that come every time. What is the roadmap to learn DevOps, right? I think like that's a good resource. But apart from that, I'll recommend you to check out Cube Simplify. That's a online open source community that releases a lot of content around DevOps, around containers, Kubernetes. So I'll definitely recommend you to take a look at their blogs and their YouTube channel as well. That's a really great resource for you to get started. And I think like as with any other organization, or like just upskilling yourself, it's not just about like learning. Like I think especially for DevOps, it's a lot more hands-on because you're not writing a lot of like code. You're sometimes, yes, you'll be writing some YAML scripts, you'll be writing some bash scripts, but a lot of it is also like understanding fundamentally how different systems work, how networking works, how, like, there are like dedicated courses you can take on Azure, probably because it's like this catered towards the Azure community. There are like tons of certifications that you can get, like Azure certified. And probably Babatunde or like Sophia, you can answer that more, because I was part of the Microsoft student ambassador club in my college. I was never a MLSA myself, but I was very actively like participating in those. But there are like a lot of active courses that are there by the MLSA community, so leverage those are really great as well.
Yeah, I'll just chime in a little bit. So, a Microsoft Cloud Advocate also created a open source resource for people that want to have hands-on experience on using, like, it will teach you about, like, from ground zero to ground 100. So you have each it's like a 90 days plan or so, where you learn Linux, you learn Bash, you learn about containerization, and you have like projects to learn about it as well. So I've put the link in the screen as well, so so that people can use the platform. And also we would have subsequent workshops on how to learn Azure, and also like different projects. If yeah, so yeah, that's it for my end. And yeah,
Yeah,
any
sure.
last, Sophia?
Yeah, nothing. Just please like the video and subscribe on the YouTube page. And all our live stream would be available on our channel, so you can subscribe. And once we have a video or a live stream, you will definitely be notified of that. So thanks everyone for joining. This was really exciting, and see you next time. Bye,
Yeah, thank you
guys.
so much, and thank you so
Thank you
much,
so
Shiv.
much.
Yeah.